let's look at inequalities in algebra. The inequality symbols look like the less than symbol, the greater than symbol, and then of course this is not an inequality, but they're used in the pretty much in the same way in equations that the equal sign is used. So we can write 2 is less than 3 and 5 is greater than 4. And you know, the way I like to remember the proper direction for these inequality symbols to point is I think of it like the pointed end can hold just a little bit of a number. So the smaller number is arranged next to the point in the symbol, and then inside here in the larger area of the symbol, it's big, so it can hold a bigger number, so the larger number goes on this side. Same thing you can see over here, the smaller number is next to the pointed end of this symbol. The pointed end can hold just a little bit, whereas this wide open area here can hold a larger amount. That's kind of how I remember which way they should be pointing. But we work with these inequality symbols and equations pretty much the same way that we work around the equal sign in equations. So in other words, if I had a simple equation like x plus 2 is greater than 4, I'm going to use my same techniques for solving this equation that I would if there was an equal sign here instead. So to solve this, I know I need to get x by itself. Let me subtract 2 from this side of the equation. And whatever I do to one side of the equation, I do the same thing to the other. That's going to leave me with x is greater than positive 4 minus 2 is positive 2. X is greater than 2. We can do some more just for practice. How about 3x plus 2 is less than 14? So I know with solving these algebra equations, I want to get x by itself. So let me take the first step by subtracting 2 from the left side of the equation. And then whatever I do to one side of the equation, I always have to do the exact same thing to the other. So in this case, I'm going to bring my 3x term straight down. We haven't done anything with that yet. And then the positive 2 minus 2 goes to 0, so that gets rid of the that term on the left side. Then I can just write the less than symbol. And then finally, the positive 14 minus 2 is 12. Now finally, to get x by itself, I'm going to divide this term by 3, and I do that because I want these to cancel out essentially. 3 divided by 3 is 1. That would leave 1x over here, and we never write the 1, it's just understood, so that leaves x. That's exactly what I want, to get x by itself. And then whatever I did to the one side of the equation, I have to do the exact same thing to the other. So I'm going to divide by 3 over here as well. That's going to leave x less than 4 for the answer. We could do one more just to prove to you that working with these inequality symbols is really no different than the working with the equal sign in equations. How about something a little different? X over 2 plus 7 is greater than 14. So the first step is to get rid of this positive 7 on the left side. So let me subtract 7. Whatever I do to one side, I'm going to do the same thing to the other. And then I can rewrite this down below. I can write this x over 2 term again. And this positive 7 minus 7 goes to 0, so it went away. And then positive 14 minus 7 is positive 7. So now I need to get rid of this 2 in the denominator of this term. So to do that, I'm going to multiply by 2 over here. So I do that so these will cancel because 2 on the bottom. 2 divided by 2 is 1. That leaves me with 1x. That's exactly what I want. But whatever I do to one side of the equation, I want to do the exact same thing to the other. So that this leaves me x is greater than 7 times 2 is 14. So you can see there is no difference really when you're solving these algebra equations, whether you have a greater than, a less than, or an equal sign. Your technique for solving the equations does not change.